the triangle congruency statements. So we have side, 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 angle, side, side, angle. So side, 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 angle, side work. We've seen that angle, angle, angle does not. Yes. Guys. Now, the that we're looking at today that do work are angle, side, angle, and angle, angle, side. Side, side, angle is one of the ways that does not work. If we have time, I'll go through and show you an example of why this doesn't work for side, side, angle. Now, the two that we're looking at today, one of them is angle, side, angle. If two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent to each other because it's going to be in the form of angle, side, and then an angle. The other one that we have is angle, angle, side. Two angles in a non-included side of one triangle are congruent to two angles in a non-included side of another. Then the two triangles are congruent to each other. We have angle, angle, side. Angle, angle, side, and angle, angle, side. Then we can say that the two triangles are congruent to each other. Any questions on this so far? Let's look at this first one here.
Is that angle side?
So we can say that these two angles are congruent because they both have one mark. We can also say that these two angles are congruent because they both two. Then we have the side length that's included in both triangles that it's shared in both. So can we say these two triangles are congruent? Angle, side, angle. Questions on this here? Right. Can we say that these two triangles are congruent? So the right angles would be congruent. Then we have these angles that both have one mark that would be congruent. Because here we have angle, a side, and an angle. Well, if we start right side and then angle. By angle, side, angle. Questions on this here? Can we say that these two triangles are congruent? By so we do have that these two angles are congruent. And we have that these two sides are congruent. These two angles would be congruent because they are vertical angles. And vertical angles are always congruent. Because whenever we have two lines that cross, they're so we have it. So these here, guys, these would be congruent by side angle, angle, or angle, angle, side. Because those would be the same. Questions on this here? Side, side. So we do know that these two sides are congruent, yes? And we know that. Do we have another set of sides or angles that are congruent? How many pieces of information do we need? Do we have three? So can we say these are congruent? No. Any questions on this here? No, guys. Tyler, guys. So if we look at this here, we do have a set of angles that are shown to be congruent. These two here. We also have this side. Question? You're good. So, guys. Well, this is going to be yes.
Oh, because the two middle
By angle, angle, side, or we can also say side, angle, angle. That's not that one. I will take that because that is against school policy. Let's look at problem number 6. So if we look at problem number 6, guys, focus up here. So what do we know? We have these two sides are congruent. And we have that. Do we have anything else?
No.
Can we say these are congruent?
No.
Any other questions?
They are congruent. Angle side.
Mm-hmm. Because we have two sets of congruent angles and a shared side, we can say that these two triangles are congruent by angle, side, angle. Okay.
Angle, side, angle. He said, oh no. And there is a side that's congruent, and that is C and D.
So the angles that we know that are congruent are right here. So that'd be angle QDC would be congruent to what? Angle EDC or CDE, because we can have either one of those three. We have to use the three letters because there's more than one angle at point D. Congruent. Because it's congruent to itself. D. Mm-hmm. So we do have angles that are congruent. So we have a set of angles that are congruent and a set of sides. Yes? And we want to say that these are congruent by angle, side. So we need another angle, and the side needs to be between the two. So right here. 1 second. So now we just need to name the angle. So in QCD would be congruent to angle CD. And this would be the one piece of information that we're missing. Yes, sir.
Okay. Anyways, why do you have two CDs?
because CD, this line, is congruent to itself because it's shared in both figures.
But why can't you DC?
That would work too, because DC and CD are naming the same line. Any other questions? So we want to see that these two triangles are congruent by side angle. Now we need to see what they gave us. Now we have these two angles that are congruent. We also have that these two are congruent. Now since there is only one angle at all of these angles, we can use the vertex. So we can say that angle K is congruent to angle what? And our other angles would be angle so we would need to know a side, yes? And the side needs to be where? Between the angles. And so guys, angle, side,
Angle.
so angle, side, angle says that if we have two angles and a side in the middle that are congruent to two angles and a side in the middle, then we can use angle, side, angle. So the side needs to be between the two angles. So we would use KL is congruent to UT or TU, yes. M is, it is an angle, but we don't need it for this here. Since we're using angle, side, angle.
Oh, so that's right.
Yep. Yes. It's on this here.
No, hold up. Why are you even up the thread? Don't say
Guys. Let's look at this one here, guys. So here we want to use angle, side, angle. We know that angle C is congruent to angle R because both of these are right angles. What else do we know? Guys. Guys. These two angles here are going to be congruent because they are vertical angles. So we could call it angle CSE or ESC is congruent to RST or TSR. Because these two here would be congruent because they are vertical angles. Well, sorry. Needs to be down there. No. Yeah. So what are we missing?
We need the side. We need the side length.
We need the side length between the two angles. R is included. CS or SC. SC or CS, RS or SR. Any questions on this here? Whenever they announce it. We're going to skip that one and go to 15. No. Guys, so we're going to look at 15 next. We're skipping one and going to 15. Because I want to look at this one here. Now this one here is angle, angle, side. Now, we are told that these two angles are, so that would be angle TDC would be congruent to angle EDC. So TDC and EDC are going to be those two angles there. And since DC is shared in both triangles, it would be a congruence in side length in both. So what are we missing? Guys. So do we have a set of side lengths that are congruent? Do we have a set of angles? Do we have a second set of angles? Well, no, because we have a side and an angle. We have another angle. Angle, angle, or angle, angle, side. We need two angles and a. So what we're missing is an angle. Well, what angle would we? E and T. E and T, but DEC would be it, or DTC. Or we can say angle DT is congruent to angle E. Since there's only one angle at these points, since there's only one angle at angle E and angle T, we can use the vertex. Questions on this here, guys? All right, guys. Let's look at this one here. So we're wanting to show that these two triangles are congruent by angle, angle, side. So we need sets of congruent angles, followed by a set of congruent sides. Well, we know that Y and are congruent because they have the same number of markers inside the angle. Since X and L have the same number of markers, we can say that angle X is congruent to angle Tyler. Guys. What are we missing?
So between L and M and Y and X. What the heck? I thought you said we needed a.
Because we need a side length. So in L would need to be congruent to X and ZX. Questions on this here?
Well, I do.
Yes.
Anyways, in the last one you said it had to be between the two angles.
Here we're needing angle, angle, side. Yes, ma'am. No, that's the same thing. XZ and ZX would be the same thing. NL or LN would be the same thing. Angle, side, side? No. Because it'd be the same as side, side, angle. Any other questions here? All right, guys. We are done for today. So the ones that work are side, angle, side, 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 angle, and angle, angle, side. HL only works with right triangles. If we have a right triangle, then hypotenuse leg would work, but we're not going to focus on it there. This is your homework.